Hello, ladies and gentlemen. It is Thursday. It is almost the weekend. We are almost there. I want to start off today by reviewing what we talked about yesterday, and we talked about factoring and expression. Okay, so let's start off with this one. We have, let's do 6 plus 12. Okay, we know that that equals 18. Okay, but when we factor out an expression, we just have to write it a little differently. All right, so first things first, our first step is to find the prime factorization of both numbers. Okay, so let's do 6. All right, so 6. The factors of 6 are 2 and 3. Okay, those are both prime numbers, so that's all we do for 6. For 12, we have 2 times 6. And then 6 is not a prime number, so we need to break that down to 2 times 3. All right, so we have 6 over here, and 6 equals 2 times 3. And 12 equals 2 times 2 times 3. Okay. All right. Second step is to find the GCF, or greatest common factor. When we do it this way with the prime factorization, we can already find out what the GCF is, what the greatest common factor is. Okay. So we need to find out what factors they have in common here. So we have 2 here, right? Those match. And there's a 2, oh, and 3. Okay. So the greatest common factor for 6 and 12, 2 times 3 is 6. That's the GCF. Okay. All right. So our third step is going to be rewrite the expression using the GCF. Okay. So our original expression said that we had 6 plus 12. So we had 6 plus 12. That equals 6, which is our greatest common factor. Let me stick with the same colors here. 6 times what? Well, 6 times what equals 6? 6 times 1. Okay, that's 6. And then plus, again, we use our greatest common factor, 6. 6 times what? Well, we did 6 times 1 is 6, and 6 times 2 equals 12. Okay, so that's pretty much it. And then our final thing, we just have to rewrite it using the distributive property. So our greatest common factor is going to be outside the parentheses. So it's going to be 6. And then we're going to have in parentheses 1 plus 2. Okay. If we were using the distributive property, we'd go 6 times 1, which is 6, plus 6 times 2, which is 12. Okay. So this equals our original expression. All right. Let's go ahead and talk about our lesson for today. It is simplifying expressions. Simplifying expressions. This is our last unit in the chapter. All right. It says when an addition or subtraction sign separate an algebraic expression into parts, each part is called a term. The numerical factors of a term that contains a variable is called the coefficient. A term without a variable is called a constant. Like terms are terms that contain the same variables such as x, 2x, and 3x. All right, well, that's a lot of words, but here's what the picture of that looks like. Okay, all right, so you see the blue arrows? It says the three terms are 3x, 7, and x. So those are the terms. Okay, 3 terms. The terms 3x and x are like terms because they have the same variable. The constant is 7. Okay. So no matter what happens, because remember, x is the variable, it's a number, we just don't know what number it is. Whatever happens to x, here we multiply it by 3 and it's x here, 7 is always going to stay the same. That's why it's called a constant. It's constant. Okay. All right. So let's move on. When you simplify expressions, you can simplify them with one variable. All right, to simplify an algebraic expression, use properties to generate an equivalent expression that has no like terms and no parentheses. All right, so here we have 3 plus 3 equals 2 times 3 or 6. Okay, here it's x plus x equals 2x. All right, so here's some examples of that. Example 1. Simplify the expression negative 4 times 6x. Here they have negative 4 times 6x. All right, it says parentheses indicate multiplication. All right, we know that. So they did equals negative 4 times 6 times x. All right. All right, and so then they're showing how that is with the associative property, and then they multiply negative 4 and 6. Okay, so really all they did here was they took 4 and they said, what is 4 times 6? Negative 4 times 6, excuse me. Well, negative 4 times a positive 6 is negative 24, and then we just keep the x. Okay, so another one would be like negative 2 times 4x. Okay, take the outside number, multiply it by what's inside. Negative 2 times positive 4 is negative 8, and then x. Okay, let's look at another example. All right, here we have talking about 3 friends. It says 3 friends will pay X dollars each for admission to the museum, plus $1 each to view the mummy exhibits. Okay, that's all important information. So let me go ahead and highlight all that. Each 3 friends, we have 3 friends. They will pay X amount of dollars each for admission to the museum, plus $1 to view the mummy exhibit. A 4th friend will pay admission but will not view the mummy exhibit. So he won't pay this extra dollar, right? Write and simplifying expression that represents the total cost. All right, so the expression 3 times x plus 1 plus x represents the total cost. All right, this is the cost of admission and exhibit for 3 friends, and this is the cost of admission for the 4th friend, because the 4th friend isn't seeing the mummy exhibit. And so they used the distributive property to distribute the 3. They did 3 times x, and then they did 3 times 1. So 3 times x plus 3, which is 3 times 1, plus this x here. All right. And then they did the commutative property, which is 3x plus 3. So they just basically grouped the x's together here. And 3x plus x is 4x, and then plus 3. All right, so the total cost is 4x plus 3. 4x plus 3. Okay. We can also simplify expressions with 2 variables. It says properties can be used to simplify or to factor expressions with 2 variables. All right. Compare the effects of operations on numbers to the effects of operations on variables. Here they have 3 plus 3 plus 4. All right, so there's our 2 different variables, right? So we have 2 times 3 plus 4. When we look at variables, it's x plus y. So x and y are 2 variables. If we add 2 x's together, that's 2x, and then we just have the y left. Let's look at an example. Simplify the expression 14y plus x plus 22y. Okay, zoom in here. Here they have it. They have our original expression here, and they just rewrote it using the commutative property. It doesn't matter which way they rewrite it, right? So they did x plus 4y plus 22y. Then they used the associative property by grouping the like terms together. So these are the like terms, right? Because they're both y's, and then there's x. Well, when we add 14y plus 22y, that's going to be 36y plus x. Okay, plus x. All right, so go back to our original expression. We did 14y plus 22y, which is 36y. And then we have our plus x. Okay, or we could write it like they did, x plus 36y, because it's commutative, right? It doesn't matter which order we put them in. All right, let's look at another example. Simplify 4 times 2x plus y